Okay, everyone, welcome back to more math videos, okay? Today we're going to be talking about factoring, and there's a lot of different ways to factor. But let's look first at what is the concept of factoring. Factoring is a concept that you have two things that multiply together to equal the product, okay? So in factoring, you're taking a product and now you're bringing it back to the factors. That is not in a good spot. It's got a glare to it. Let's try right here. Can it be seen? Yes, it can. Okay. So if I have the number 12 and I want to factor this, I have factor sets. I have 1 times 6 is one way to factor it. 1 times 12 is a way to factor it. Get the right number here. 2 times 6 and 3 times 4. Each one of these is a factor pair. Okay, so 1 times 12 equals 12, 2 times 6 equals 12, and 3 times 4 equals 12. I can also do what is called a prime factorization, and it would be 2 times 2 times 3. So that would give you a prime factorization. And your prime factorization is unique. In other words, every number has one prime factorization to that number. So what's going to happen now? Now we are going to look at expressions and look and see how we can factor these polynomials. So the first factoring method we're going to look at is looking at a greatest common factor. Now, what do we do to get a greatest common factor? Well, let's look at something simple. If I did 6 times x minus 3, which we call the distributive property, this was 6x minus 18. So now we're going to take this binomial and we're going to look for a common factor in that binomial, okay? I always look at my smallest number and ask myself, does my smallest number go evenly into my larger number? In this case, it does. So therefore, this is 6 times x, and then 6 times 3. Okay? So if I take my 6 is my common factor, and I pull it out to the front, and what is left? X and 3, and I have a minus here, so I have a minus here. And that gives me 6 times x minus 3, which is my original factors that produced this binomial. So we're going to be looking at finding greatest common factors in various numbers, okay? And expressions. And some will be my binomials, some will be more. So let's just do some practice on finding common factors, all right? So let's look at the number 18 and 24. If you look at the number 18 and you write its factors, you have 1 times 18, 2 times 9, 3 times 6. So that's all the factors of 18. Now let's look at the factors of 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So those are all the factors of 24. So now let's look at what they have that are the same. 1s are the same, 2s are the same, 3s are the same, 6 is the same, and none of the others are the same. So your greatest common factor in this case would be the number 6, because 6 goes into both 18 and 24, and it's the largest of the choices. So this is one method that you can use to find the greatest common factors. So what happens if we have variables now? We can always look at the variables first us, what does it mean? X to the third and x to the fifth. X to the third is equal to x times x times x. X to the fifth is x times x times x times x times x. When we look at this, we have 3 and 3. You see that? I have x as a factor 3 times in both of them. So therefore, my common factor here is x to the third. And this is, notice that your common factor for variables is the variable with the smallest exponent, because 3 is smaller than 5. And therefore, that will give you your exponent common factor. So now let's look at things a little more complex. Let's go back to a binomial. For x minus 12. Notice this is 4 times x. This one is 4 times 3. My common factor is 4. Pull it out to the front. I'm left with x, and don't forget this is a minus here, minus 3. And that is a greatest common factor of that binomial. Let's look at a bigger one. 6x to the fourth plus 18x squared, no, x to the sixth, get my right number here, and minus 24x to the eighth. So, notice 6 times 1 is 6, 6 times 3 is 18, and 6 times 4 is 24. So therefore, this gives us, and this is x to the fourth, plus 6 times 3 times x to the sixth, minus 6 times 4 times x to the eighth. Here's our common factor of our 6. And this is my smallest exponent is my x to the fourth, x to the sixth, and x to the eighth. So x to the fourth is going to be my common factor. So this will be x to the fourth times x squared, because 4 plus 2 equals 6. And this would be x to the fourth times x to the fourth. X to the fourth, 4 plus 4 is 8. So this gives me my common factor of x to the fourth. All of those are pulled out. That leaves a 1 here on that one. This one's gone and this one's gone, leaving this one here. This one's gone and this one's gone, leaving this one here. So now what's left to go inside? 1 plus 3x squared minus 4x to the fourth. And notice that is now completely factored. So we have every one of this is a greatest common factor has been pulled out. Another method that I have seen people use, and they really like it. And some people like this method better than this method that I just showed you. So let's look at another method that might be helpful for some of you. And that's, let's put our 6x to the fourth here, plus 18x to the sixth, minus 24x to the eighth. So, we're going to draw a line under here. And we're going to look at that common factor of our numbers first. And it's going to be 6. So 6 times 1 is 6. 6 times 3 is 18. And 6 times 4 is 24. So we'll bring down our x to the fourth, the plus, x to the sixth, and the minus, and x to the eighth. Now, we're going to look for another common factor. Okay? So, what are we going to do? Well, x to the fourth is my smallest, so let's do it. x to the fourth is gone, leaving 1, plus x to the fourth means 6 minus 4 leaves x squared, minus 4, x to the eighth, 8 minus 4 leaves x to the fourth. This is all the way factored. You don't have any more common factor in it. So you multiply these two together and have 6x to the fourth times 1 plus 3x squared minus 4x to the fourth. So there is a way to factor your greatest common factor out. We could also have factored out a negative number. And you'll have a problem or two that they ask you to do that. So let's look at this again. And instead of taking a positive 6 out, let's take a negative 6 out and look what happens. Okay? Negative 6, x to the fourth. And that's going to leave me negative 1 because negative times negative gives you that positive. And a minus 3x squared. And a plus, because negative times negative gives a positive. And a plus 4x to the fourth. And again, negative times a positive gives a negative. So as you see, if you take a negative factor out, all the signs are different from the one where you took a positive factor out. Okay? So now let's look at pulling a common factor out that is not just a monomial. We're going to look at pulling out a polynomial factor. 5 times 2x plus 3 plus x squared times 2x plus 3. So notice, this expression here, 2x plus 3, is a binomial, but it is a common factor. So what's going to happen? We're going to pull the binomial out this time, and you're going to have to keep it in parentheses because that whole thing is one factor. Now, what's left? 5 plus x squared. This and this gives you your second factor. And like everything else, we can always check it by multiplying it together again. Using your FOIL method, you would go right back to what would happen if you'd actually multiplied that out. So that gives you that one. Let's look at another one. Oh, I'm going to need more space to do this one. $15 times 2z plus 1 cubed plus 10 times 2z plus 1 squared minus 25 times 2z plus 1. Okay, this one is going to be a lot more complex. As you can tell, my 2z plus 1 is my common factor, but here it's to the power of 1, to the power of 2, and to the power of 3. So when we go to pull it out, we're going to have to treat it like a variable and deal with the powers. So I have 15, 10, and 25. So my common factor is 5, and 2z plus 1 is that common factor. Now, what's left? Well, 5 times 3 is 15, so 3 is here, 15 divided by 5. 2z plus 1 to the third minus 2z plus 1 to the second will be 2z plus 1 squared. Okay, 10 divided by 5 is 2, so that's a plus 2, times 2z plus 1 squared, and 2z plus 1 to the first. 2 minus 1 is 1. So you're left with 2z plus 1, and then minus 2z plus 1, and 2z plus 1 is exactly the same, so 25 divided by 5 is 5. And there it is. Now, you can continue to simplify this by multiplying this, and then we'll combine like terms. So you have 5 times 2z plus 1, 3 times 2z plus 1 times 2z plus 1. You're going to use your FOIL to calculate that. 2z times 2z is 4z squared, plus 2z times 1 is 2z. 1 times 2z is 2z, and 1 times 1 is 1, plus, let's distribute this one. We end up with 4z plus 2 minus 5. Okay? Now let's simplify this. This is 4z squared plus 4z plus 1. And now let's go ahead and distribute the 3 to each one of those. So we have 5 times 2z plus 1 times, and we're going to eliminate our parentheses, so we'll go to parentheses. 3 times 4 is 12z squared, plus 3 times 4 is 12z. 3 times 1 is plus 3, and now plus 4z, and how about 2 minus 5 will be a minus 3. Okay? Let's continue simplifying. 12z squared, nothing like it. 12z plus 4z is 12z squared plus 16z. And this is 3 times 3 minus 3 is 0. So we end up with 5 times 2z plus 1. Now notice, this has a common factor again. So we can factor that common factor out. So we have 5 times, and let's put that here. 12 and 16 has a common factor of 4 and a z. So 5 times 4z times 2z plus 1, and then times 3z plus 4. And now 5 times 4 gives you 20z times 2z plus 1 times 3z plus 4. And there is that problem all the way factored. It was kind of a long one that goes on and on and on, okay? That's the end of the first method. And now we're going to look at how to factor a 4-term type of thing. And it's called, we'll get there when we get there.